everyone, and welcome to today's webinar, Time to Revisit RNA Preservation, Synergy Blood Collection Tube. I'm Christina Jewell of LabRoots, and I'll be your moderator for today's event. Today's educational web seminar is presented by LabRoots and brought to you by SIO2. For more information on our sponsor, please visit sio2ms.com. Now, we encourage you to participate today by submitting any questions you may have during the presentation. To do so, simply type them into the Ask a Question box to the left of your screen and click Submit. We will answer as many of your questions as we have time for at the end of the presentation. You may also submit any technical issues here as well if you have trouble seeing or hearing the presentation. I would now like to welcome our speakers. Chris Weikart, Chief Scientific Officer, Ishfaq Maksud, Molecular Scientist, and joining us for our live Q&A is Pete Sagona, Senior Vice President of Business Development. For complete biographies of today's speakers, please visit the presenter bio window at the right of your screen. Gentlemen, it is so great to have you here with us today. You may now begin your presentations.
Thank you. Thank you, Christy. I appreciate the introduction. Good day, everyone. Thank you for joining us and showing your interest in SiO2 as well as our Synergy blood collection tubes. Before we get started, though, I just wanted to share 2 points. One, next week, there'll be the Association of Molecular Pathology Conference and Expo in Salt Lake City, and we'll be in attendance there. We'd be happy to follow up with you after this presentation and re-engage. Second, I just did want to point out that we do have a 25% discount on our products, so please feel free to go to our website. We'll have the QR code a little later, and you can order the product there. Okay, so to start things off, I'd like to give a brief introduction about our company and also about the Synergy blood collection tube technology. The bulk of the presentation will be spent on the preservative formulation as well as the benefits for nucleic acid preservation, particular focus on RNA, and then as well as the competitive advantages of the product that it brings to molecular diagnostics. So who are we as a company? Basically, back in 2012, the company was built on the knowledge that children were having adverse reactions to life-saving drugs. And it wasn't due to the drug, it was because glass packaging was shedding particles into the drug product, and that negatively impacted the drug itself. Now, this is a real problem with glass that still happens today and has led to many product recalls in the past. We've made it our mission as a company to develop safer packaging solutions that eliminates the particle problems as well as many other issues that are commonly associated with glass. So you can see here we have a good track record of successful product launches over the past 10 years or more. And this includes things like an ophthalmic syringe that we developed specifically for Novartis for a Lucentis drug product. We also supplied vials to Moderna during the pandemic for their COVID vaccine. And then more recently, of course, the Synergy blood collection tubes for liquid biopsy diagnostics. Our company's located actually in Auburn, Alabama, in the United States. This is about an hour and 20-minute drive from the Atlanta airport in Atlanta, Georgia. We've got about 14,000 square meters of state-of-the-art Class 7 clean rooms where products are manufactured and inspected. Basically, the technology is manufactured in a fully automated unit operation environment with no direct human contact. Of course, this ensures that the product is clean with very low endotoxin bioburden, so a completely sterile product, of course. And all of these products are sterilized at third-party vendors, which basically renders it either ready to use or ready to fill. And in the case of blood collection tubes, we gamma irradiate these tubes so that they are sterile. So we've got a diverse portfolio of products, as you can see here, for 2 key application areas. This includes the primary packaging for biologic drugs and vaccines. And this are things like vials, cartridges, and syringes. And then the other area is focused on diagnostics with products such as our Synergy blood collection tubes, as well as molecular transport media tubes. We're also well equipped with fully automated for both of these products. So now just a brief overview of our technology, the tubes themselves. The Synergy tubes are how I would say a unique blend of the best of glass and plastic materials. We first mold the tubes from a medical grade polymer, and then we deposit a very thin microscopic layer of a glass-like material on the inside of the tubes. And of course, that enables a unique blend of benefits and features. And Synergy tubes provide 2 years of consistent, reliable vacuum retention. Of course, this leads to consistent blood draw volumes from patients. You would expect this from glass. Of course, this tube is made primarily from plastic, but this very thin layer of glass provides that advantage. You also get the durability and toughness of plastic. This ensures safe handling and eliminates any breakage-related injuries to medical professionals. If you would like to learn more about our products, we publish a few things here. You can see we've got a couple papers and, of course, some patents on the technology for the tube. And if you click on this QR code, it will take you to our website, and you can take a look at these in more detail. So with that, I'd like to pass the torch on to Ishfaq, and he will take the rest of the presentation. Ishfaq?
Chris, thank you, Chris. Hey, everybody. I'm Ishfaq Maksud. I've been working on the Synergy tube the last few years, and I love this opportunity to be able to speak about it with all of you. As Chris focused on the company history and on the materialistic properties of the tube, the material properties of the tube, I want to focus on the preservative and the benefits it brings. So let's start. The formulation. It's proprietary, but what I can tell you about the tube is that it has made up of salts and water-soluble polymers. Also, it doesn't have, it's formaldehyde-free, and it doesn't use cross-linking chemistry as other tubes do on the market. What the Synergy preservative helps do is it helps prevent hemolysis and prevents genomic DNA contamination. It also helps us skip cold chain shipping, particularly for RNA, and it helps us save time on the bench, specifically for blood tube processing before we have extraction preparation. Let's look at the blood draw volume. Synergy has comparable blood draw volume to standard 10 ml blood tubes on the market, such as Strec and EDTA. Our preservative is about 1.4 mils, and our blood draw volume is a little over 8 mils. Let's switch to the cold chain shipment. Whereas a standard blood collection tube will need a phlebotomist who not only has to focus on the blood draw, but also on how the blood tube has to be stored following, with temperature controlled storage, followed by, to send the tube over to the lab or the testing facility, it has to be shipped on cold ice or some sort of cold packaging, right? Along with transportation and temperature controlled method. And finally, when the tube actually gets to the lab or the testing facility, it has to be put in the refrigerator. Compared to a standard blood collection tube with the Synergy tube, we still need a phlebotomist for the blood draw. However, after that, it's very, very straightforward in terms of having regular room temperature storage, followed by regular packaging and standard transport. And the best part of it is when it gets to the lab or the testing facility, it doesn't have to be stored in the fridge. It can be just left on the lab bench until it's time to extract. Here's a look at a case study where the blood tube processing is compared between, for a customer, between Paxton tubes, which they were using at one point, and the Synergy tube. To start off with the single patient, there needs to be two extractions, two blood draws of when using Paxton tubes, whereas with Synergy tube we only need one blood draw. We'll focus on why in a few minutes. So in this case study, with this current customer, what they do is they have one patient draw two blood tubes of Paxgene RNA tube, which is a standard for RNA, right? In order to get to the extraction step, which they currently use with MagMax RNA isolation kit, they have to go through a centrifugation step, then decanting, followed by adding water, vortexing, centrifuging again, and decanting again. This entire process takes about 20 to 30 minutes and adds on extra time before even extraction can begin. Compared to that synergy tube, all you have to do is invert the tube a couple of times. And this is at room temp, right? So we get this from room temp, synergy tube, we invert it a couple of times and transfer 400 microliters directly from the tube onto a plate. And the example here showcases how our customer is using Beckman Coulter RNA advanced kit for RNA extraction. So whereas with Paxgene RNA tubes, we have to go through multiple steps of centrifugation and decanting, which delays the process. With synergy tube, we can jump directly into the extraction process with just one transfer with P1000 of 400 microliters. Not only that, with the Paxgene tube, we have to use the entire tube for one extraction, whereas with the synergy tube, we can have multiple extractions from one single tube because it just needs 400 microliters of blood at a time for extraction. Now looking at the plasma volume. With the synergy tube, we maximize the amount of plasma we get out of the blood tube as well. We get more than 5 mils compared to STREC and EDTA. And it's a simple process of centrifugation of at 430 Gs for 15 minutes, and then transferring to a 15 mil conical for long-term storage. Now let's focus on the important part, which is the RNA preservation performance with the synergy blood collection tube. We want to look at the quality metrics. We've already gone over the blood draw and the plasma volume earlier. We want to take a look at hemolysis, and then post-extraction, the yield, purity, and integrity of the RNA, along with the compatibility of the RNA, that's extracted with NGS technology downstream. So here's a look at the hemolysis graph. This is over 30 days, and compared to STREC and EDTA tubes, as you can see, the presence of hemoglobin contamination is minimal or completely not even there, right, with synergy tube, which is the light blue color line at the bottom. When you see the EDTA and STREC tubes, they start increasing drastically after the 14-day mark, whereas synergy remains 0. Though this helps it helps with a lot of downstream diagnostics because it minimizes the amount of GDA contamination and hemoglobin contamination because of the lack of hemolysis. Now let's turn to the actual extraction and its actual extraction of RNA. So here's a look at a comparison between synergy and the Paxgene RNA tubes, which is a standard for RNA again in the industry, right? So this is all at room temperature. The yield is more than double of what Paxgene gets with synergy. The purity is on par with Paxgene, between Paxgene and synergy. And the focal point, the RIN value with synergy is much higher than with Paxgene, especially at the day 7 mark, when synergy is approximately of the RIN value of 7, whereas Paxgene drops below 5. And this is all using the standard bioanalyzer instrument that we get these results. Now here's some downstream application with NGS with synergy tubes when RNA is extracted with our preservative. We conducted a study where we took blood samples from 5 healthy donors with synergy and with Paxgene. Then we did our RNA extraction downstream with synergy and Paxgene, and then we compared the QC metrics that we got between them. What we saw for the RIN values was they were highly intact in both synergy and Paxgene tubes with a value of above 8.5. And then when we went down to NGS, the number of reads we got were in 27, 28 millions, and they were fairly comparable between Paxgene and synergy tubes. What you can tell from this data is that the number of reads we extract from synergy is very comparable to industry standard of Paxton RNA tubes. And as looking at the next slide, we can tell that the quality of these reads are very, very high as well, with a quality score of above 34 for synergy and Paxton. And we also get to see that they're all mappable to the transcriptome above 98%. What this shows is the synergy tube gives us extracted RNA that's ready for downstream application, such as NGS with high quality data. So please give this a try and let us know how it works with your downstream NGS applications. Now let's turn to offering competitive advantage and how the synergy tube performs there. Here are some benchmark competitor blood collection tubes based on the specific analytes. For gDNA, the industry standard, most people use EDTA. For cfDNA, Streck tube, the glass Streck tube is primarily used. And for RNA, as we mentioned earlier, the Paxton RNA tube is used. With synergy, we can combine all three analytes in one tube. So synergy tube can preserve all of these three analytes with a single tube without having to divide into three different tubes. Here's a look at the gDNA preservation with synergy. Compared to EDTA tubes, our yield, purity, and integrity are comparable and at par. And DIN value, the purity, and the yield showcases that not only does synergy preserve RNA well, but it also is very comparable with gDNA preservation. Now turning to cfDNA, which a lot of the audience members, a lot of you folk have showed specific interest on, right? With cfDNA preservation, primarily Streck tubes are used. However, Streck brings with it an issue of gDNA contamination. With the synergy tube, we prevent the gDNA contamination in our cfDNA that's extracted, and that can be seen in this yield and integrity graphs here. So on the yield graph, you can see that Streck gives us about 18 nanograms per mil concentration, whereas synergy gives us about 5 nanograms per mil concentration. However, this synergy is gDNA contamination free. And you can see that in the following graph on the right, where the DIN values are represented. The DIN value for Streck is much higher, showcasing a lot of higher long chain nucleic acids compared to the short chain nucleic acids, which are predominant in synergy. This shows the gDNA contamination in Streck is quite a lot, especially after day 14, whereas with synergy, it remains minimal and consistent throughout the entire 30 days. So this is cfDNA at room temperature with synergy. Here's a summary of the competitor matrix again, overviewing the three analytes again. With the SiO2 synergy tube, we have good plasma volume, we get low hemolysis, we have cfDNA stability for over 30 days, we get RNA stability at room temperature for 7 days, and we also have gDNA stability for over 30 days. The BD's Paxton RNA claims 5 days, 3 days stability at room temp, whereas Streck's cfDNA tube claims 7 days stability at room temp. BD's EDTA gDNA tube has no specific claims, but is very comparable to our synergy tube gDNA preservation. We also conducted a temperature stability test to see the effects of varying temperature on the preservation with synergy. And as you can see, at 4 degrees, cfDNA is preserved for 60 days. At room temp, it's preserved for 30 days. And at 37 degrees, when the temperature is increased, cfDNA is still preserved for 10 days with the synergy tube. We can also freeze thaw the tube more than 3 times with good quality results with extraction. Similarly, for gDNA at 4 degrees, we have a preservation life of 60 days. At room temp, we have it for 30 days. And at beyond 37 degrees, we have a preservation of 10 days for gDNA. And again, with 3 times freeze thawing ability. Now, when we switch to RNA at 4 degrees, we have 15 days of stability with synergy. At room temp, it's 7 days. And at 37 degrees, it's 3 days. And as we mentioned earlier, Synergy can handle all your downstream applications by providing high-quality RNA, cfDNA, and gDNA preservation. We could turn to traditional qPCR or digital PCR for neonatal cancer and other disease diagnostics screenings downstream. In our own lab, we use digital PCR for quality metrics detection post-extraction. Also, we've sent our extracted RNA to third-party labs for library preparation, giving us beautiful RNA-seq results with great quality run metrics. We also have preliminary data on protein screening with ELISA and cell viability studies with flow cytometry. If you guys are interested to find out, please let us know in the questions. Here's a customer case study and benefits conveyed to us by a molecular diagnostic lab. So this is a West Coast well-established molecular diagnostic company that is validating the Synergy tubes right now for RNA use. And these are the benefits they claim to have received with transitioning to Synergy. With SiO2, Synergy provides a domestic supplier. And post-COVID, that's a very, very big part of the business nowadays in continental US. Also, we eliminate the need for cold chain shipping, which has been a big help to that company. We also reduced the time it takes for prep time at the lab bench, as I had indicated earlier, compared to their current use. And that saves a lot of time for people who work in the lab, they know. In order to get extraction started off instantly, it's very, very helpful to have the blood tube preparation processing time cut short as little as possible. And that helps not only to start off the extraction, but also helps start off automation for the extraction kit for the blood tube. And then downstream processing speeds up because of that. Overall, it also helps this particular customer lower the cost of goods, specifically because of our competitive pricing, and also because we offer a paired analyte testing, where we can combine multiple analyte testing with one tube. So here's the screen with a QR code if you're interested to order the Synergy blood tube today. And what we can guarantee is we have 7 million units annually. We have the capacity to make 7 million, over 7 million tubes each year. So feel free to place your order. And Synergy BCT is currently available as an R&D, as an RUO product with a tested shelf life of over 2 years. We have the offerings in a count of 25, 50, and 100. And because you attended this webinar and put up with listening to me, you'll get a 25% discount. Next week, we're also attending the AMP conference, which is annually held. And this time it's going to be in Salt Lake City. So feel free to stop by and meet us in person. And we can talk more about the Synergy tube and the benefits it can provide to you and your company and your customers. Thank you again. And we're open for questions, feedback, comments. Let me get back to our QR code in case you did not catch that.
Perfect. Thank you, Ishfaq and Chris. And welcome back, Pete. It is now time for our live Q&A portion of our webinar. So as a reminder to our audience, if you haven't submitted any questions yet, please do so now. Just type them into the Q&A box, click submit, and we will answer as many of your questions as we have time for. Okay, we have some great questions coming in. Let's go ahead and start with this one. Could you restate the solution volume versus the blood draw volume?
The solution volume. I think I'll take that question, yeah. Yeah, regarding the solution volume, I think that's the preservative solution volume. The preservative solution volume is 1.4 mils. So that's in the tube pre-blood draw. After the blood draw, it's a 10 mil tube. The blood draw volume is up to 8.5 mils. And that's consistent, as Chris mentioned, with the vacuum seal properties of the tube.
That's right, yeah.
Great. Okay, Chris, let's go with this one for you. What kind of breakage testing have you performed on the blood collection tubes?
Yeah, that's a good question. Of course, as I mentioned before, these are pretty tough tubes. They can take quite a bit of abuse, but we did run some fairly standard testing where these tubes were filled and dropped from a couple different heights. I think we did a 4-foot and a 3-foot drop onto a laboratory hard surface on the laboratory floor. And we did the same comparison with that of standard glass tubes. And not surprisingly, you obviously get some breakage with the glass. Not 100%, but depending on the fill and the height, you'll get a percentage of those tubes that will break. Whereas the Synergy tubes basically have no breakage whatsoever, no fracturing or any sign of damage, which is obviously a big benefit. You don't have to go back and redraw that blood into those tubes, which can be quite a hassle, obviously, for the folks. And of course, it's a hassle for the patient. I mean, you don't want to have to go back and redraw blood. So, but yeah, those are the tests that we've run on filled tubes.
Thanks, Chris. Ishfaq, I believe this one will be a good one for you. What is the average yield for an RNA extraction conducted on whole blood preserved with Synergy, between 80 and 100 nanograms per microliter?
Yeah, it is actually about 80 to 100 nanograms per microliter. Let me go back to the slide that presents that. So it'll be more, yeah. So here, as you can see, the actual yield for when RNA is extracted, we use the Beckman, and we recommend using the Beckman culture kit. However, we're open to extracting with various other kits, depending on who wants to collaborate with us in an effort to optimize their kits with our tubes. We can extract approximately 4 micrograms per mil of blood that we get, and the exact concentration in nanograms per mil about between 80 and 100. And that's our yield. And that can be sent downstream for NGS or other downstream applications.
Thank you. And speaking of kits, if you could elaborate on what extraction kit is best to use for RNA extraction with a Synergy tube.
Yeah, that's a good question. Yeah, we've tested multiple kits out. What we recommend is to use the Beckman culture at this point. However, we're open for collaboration with various kit companies to see which extraction kit can be optimized or packaged with the Synergy tubes at this point.
If I may, Ishfaq, I think that the advantages that were shown in the presentation about not needing the cold chain, and particularly the streamlined sample prep in the laboratory, would hold true for all of the sample prep kits. And so I think we've had experience with a subset, and we really look forward to having an opportunity to work closely with other sample kit manufacturers to evaluate the Synergy tube, and then find out how it can work for that sample prep kit to offer those important benefits to the end customer, the laboratories.
Mm-hmm.
Yeah.
Totally.
Thank you. Now, Pete, I believe this one would be best directed at you. Could you speak about the manufacturing capacity of SiO2?
Thank you, Christy. Yes, in the last slide with the ordering information, it says that we currently have capacity for 7 million Synergy tubes per year, but we are by no means limited to that number. SiO2 has a manufacturing campus with 14 lines of manufacturing capacity that can be repurposed for different types of primary containers and blood collection tubes. So the 7 million per year is really only one of 14 lines. We can repurpose lines as the business grows, and so we really have an ability to supply more than 50 million units as the business demands it. So SiO2 has made a big investment in the manufacturing capacity for Synergy, because we really believe that this offers important benefits to the molecular diagnostic testing industry. Thank you.
Christy,
Thank
may
you,
I
Kate, for
make?
elaborating.
I'd like to just make one comment while we're on this slide, and this kind of carries over from what Pete was saying. But you can see here, it indicates that our tubes are research use only, but we are in the midst of pursuing a 510K, and we're embarking on that as we speak. So we hope to have that in hand next year. In the meantime, Ishfaq was talking about a case study with a customer on the West Coast, and we are in the process of a verification and validation of our tube on an automated line with a customer, and they are very excited to do that because of the many benefits that Ishfaq has outlined here. This is to replace an existing in vitro diagnostic test that they're currently using with an existing product, and they're obviously operating within in a CLIA lab. But one of the things that really got them interested in us was in the throes of the pandemic, and that was because they had a hard time getting competitive tubes. Well, tube that they were using at the time. It was difficult, and because it was sourced internationally, and very difficult to find an alternative domestic supplier. And so they definitely are interested in us for that reason and many others. But if ever there was another pandemic and there was an issue, it's always nice to have a secondary supplier that's right in your backyard. So.
Thank you, gentlemen. And Chris, Ishfaq, this probably one of you can answer this one. Could you expand on the statement that cfDNA, RNA, and gDNA can be extracted from the same tube?
Yes, I can pick up on that. Yeah, what Synergy offers, that's a really good question. What Synergy offers is a competitive advantage, right? That's something we focused on the presentation, is that not only can you extract RNA from a Synergy tube, from the same blood tube, with just the same, from the same blood draw, you can also extract cfDNA and gDNA as well. Because RNA only uses 400 microliters of the actual blood draw, from the blood draw, the remaining volume can be used for plasma extraction, with a plasma separation, and plasma separation for cfDNA, and decanting for cfDNA, and also for gDNA. The blood itself could be used for gDNA extraction. So it can be used all in one, from one tube, compared to other competitors, which you have to have various tubes for various analytes. With Synergy, you can do all three in one because you don't use the entire tube volume as the standard RNA tube, such as the Paxton RNA tube on the market. You have to use the entire tube when using Max extraction kit with it. I don't know if that answers the question. I think that's the gist of it. Where. Cool.
Great. Well, thank you. And if it didn't, we can have our attendee submit more questions on that one. So.
Yeah.
But there is enough. There's enough sample that can be removed, can be procured from the Synergy tube, where you can aliquot the samples that you need for the various types of, whether it's gDNA, cell-free DNA, RNA, and have the laboratory process those specifically for those tests. So it would require likely some reconfiguration of the lab around more aliquoting of the single tube, as opposed to having dedicated blood collection tubes. But that, my understanding is that's a routine thing that's done in laboratories.
Yep, and just one more item. And because Synergy has a 2-year shelf life, you can purchase Synergy specifically for RNA and use it for gDNA or cfDNA as well. Instead of purchasing one tube for one purpose, you can purchase Synergy and apply it to multiple purposes. And I think the 2-year shelf life really, really helps with that.
Thank you. Our next question. Does the sterilization of the blood collection tube affect its color or appearance? Chris, maybe you can answer this one?
Sure, yeah. Yes, as I mentioned previously, we use gamma irradiation to sterilize the tubes. And of course, depends on the dose that you use to sterilize. It certainly can impact the color if the dose is too high, but we've optimized the process such that we get the optimal sterility without impacting any color change. The worst case that can happen is there will be a color change initially, and actually it's a reversible process. It goes back to clear within within days of irradiating the tubes themselves. So basically, if you held a tube that was not irradiated and one that was irradiated side by side, you couldn't tell the difference between the two. So no impact on color or any other properties of those tubes.
Very good. And let's see, we have some more questions coming in. Let's go with this one. Can we pull off 4 milliliter of cell-free plasma from each tube? Since the reservation solution volume is so high, are you not effectively diluting the plasma?
Possibly diluting the plasma, but let's switch to our plasma extraction volume. Where are you? Here. So here. So the plasma volume that we do get from our blood draw of 8.1 to 8.5 mils of blood draw is above 5 mils. So what this enables us to do is conduct extraction of not just 2 mils, but of 4 mils, right? So we can extract up to 5 mils of plasma. This does dilute a little bit, but what it does help do even more so is prevent gDNA contamination. Our preservative strong point is preventing gDNA contamination. And because there's minimal hemolysis and minimal gDNA contamination, the amount that you do extract, you don't have to purify. You can go directly from cfDNA extraction into your downstream application. You don't have to worry about purifying it and losing content when trying to switch into getting high quality cfDNA. So give that a try. Yeah, feel free to, so Hannah, right? So Hannah, feel free to place an order, get a package of Synergy and test it out yourself. And we can collaborate more on seeing how we can make Synergy work for you.
Thank you. And I think we can fit one more question in. Does the tube suffer from moisture loss like ordinary plastic? And how does that impact the preservative shelf life?
Yeah, thanks, Christy. Yeah, so the polymer that we use for the tubes is a cyclic olefin polymer, and it actually has very good moisture barrier characteristics compared to other ordinary plastics like PET, which is a common material used for blood collection tubes. So you will get about a 5-fold better barrier to moisture, which obviously minimizes the amount of moisture loss over the shelf life. We've seen other products over the course of a year or so, or even less, with standard polymers, where the preservative goes from like a liquid to almost like a gel. Again, it's evaporating off. So we don't see that at all. We have, we guarantee 2-year shelf life with no chance of changing the properties of the preservative, and certainly gelation has never been observed. Again, just because the polymer is such a good barrier to moisture.
Thank you, Chris. And Ishfaq, Pete, thank you all for this great Q&A session. Before we close, do you have any final comments for our audience?
Yeah, Christy, I just like to say thank you to everybody for attending this. And again, I just like to reiterate that we'd love to do any follow-ups after this. We will, again, be in attendance at the AMP meeting next week in Salt Lake City. So it's a great opportunity to meet face-to-face and have some further dialogue. We do have some technical brochures that you'll find on the website, but we'll also be handing those out at the conference. We've got more thorough technical data that if you'd like to see, we'd be happy to share that with you. And of course, feel free to order our product online, given the discount that we're offering today. So with that, thank you. And I wish everybody a good day.
Yes.
Thank you, Christy. Thank you, everybody.
Christy, thank you very much. Thanks to everybody for participating and listening. And we're very excited to present the Synergy Tube to you today. Thanks.
Yeah, thank you.
Yep, looking forward to that.
Thanks, Christy.
Thank you, Christy.
Absolutely. And You bet. And I want to thank you again, Dr. Chris Weikart, Ishfaq Maksud, and Pete Sargona for their time today. I do want to thank LabRoots and our sponsor, SiO2, for underwriting today's educational webcast. Before we go, I do want to thank our audience also for joining us today and for their interesting questions. Now, questions we did not have time to get to today, and additionally, those that are submitted during the on-demand period, they will be addressed by our speakers via the contact information you provided at the time of registration. Today's webcast can be viewed on demand, and LabRoots will alert you via email when it's available for replay. So we encourage you to share that email with your colleagues who may have missed today's live event. Thank you for joining us. Gentlemen, it's been a pleasure. Have a great day, everyone.
Thank you. You too.
Take care, Christian. Bye-bye, everyone.
Bye-bye.
Take care, everyone.